Welcome friends to a new session on our Chai Coffee channel. So today me and Samir we are going to introduce you to another interesting technology called Apache Kafka. So before going into the details of technology and knowing more about the technology, let me just quickly set a little bit of context about how the businesses have changed in today's world. So today if we see majority of the businesses have become really very complex. Like they are largely dependent on each other. Like for example, let's say if you order something on a food ordering app, like I order just a coffee on Zomato app. So typically if you see there is a Zomato app which is accepting my order, but behind that, apart from Zomato's infrastructure, there is a restaurant which is going to process the order. Then once the order is ready, then there is a delivery organization which is going to deliver. And then there is a payment gateway from where the payment is going to get deducted and so on and so forth. So lots of businesses, they come together to fulfill a small business requirement like ordering a coffee. So behind the screen, it has really become very complex. So whether it's a large enterprise or a marketplace or a planet scale application, something like a food ordering app or maybe an Amazon, etc. Day by day, the businesses have become largely dependent on each other. And then because of that, it has put pressure on all the underlying systems which are delivering that business experience. So Samir, before going into the Apache Kafka detail, I just wanted to check with you, like for all these new systems, so what are the expectations from these systems are today?
Correct. I think whether we are talking about these web-centric, app-centric user or retail-facing applications, or whether we are talking about the enterprises, right, the bankings and finance companies and telcos, etc. Right, a lot has changed, and these expectations are building up in terms of like you mentioned, you ordered a coffee, right, or I ordered a chai, right. And both the experience that we get, that matters a lot. And this experience that is being given by these applications, right, it's putting a lot of stress on the applications which are behind, essentially, right? So if you look at the expectation in general, right? So first of all, you and me and everybody today expects this whole interaction that we do, right, of buying a chai or a coffee or ordering whatever you want, right, masala dosa, whatever it might be, right, or buying something from Amazon, we expect it to be really fast, super fast, right? Few click of buttons, and you expect the whole transaction to be over in the real time. So this real time communication, real time transaction, that in my mind is one of the first and most important change which has happened over the years.
Yeah. Absolutely. Yeah. I think that's, and if an application doesn't give that fast response, then the consumer is going to go on another application, the competing application.
You keep switching fast because you have so many computers around here now. So exactly.
Absolutely.
So that's the first part. I think second, if I think about it, then it's obviously that we today have got used to application never failing, right? I mean, maybe 10-20 years back, you would try and retry and try to log in again and all that. Those days are gone, right? Your app is always on, and if app doesn't respond, you uninstall it and you install a computer app, right? So app should never fail, essentially, right? That has become the norm nowadays, right? So in our term, if you look at the system, that means the system have to be really fault tolerant, right? You have to build overall fault tolerance in your application, in the orders and messages that you are taking in and all that. And ensure there's a replay at every stage and nothing is lost. So being able to never fail. And the next point also is related to that, which means extremely reliable, right? So even if there is a blip somewhere, you talked about a very complex supply chain, right? Connecting everything together. If any part in that supply chain, for whatever reason, fails or doesn't respond for some time, right? Still, the overall experience of the overall transaction has to be extremely reliable, right? I mean, you can't, after everything goes through, you don't want the app or Zomato to come back and tell you, hey, sorry, something went wrong. Can you reorder again your chai? No, I mean, it just won't work, right? So that is a reliability angle. That's what I feel. I mean, you also would have, had the same experience, right? Well, when you were running your own applications and
Yeah. And then the key thing here is that probably for the user, it is just a small application which is running on the mobile. but there are lots of systems which are behind, so they also should be reliable. They should never fail. So I think a lot of stress is there on those systems, because local application
Exactly.
will work only if those systems are really working fine.
Exactly. So fault
Yeah.
tolerance and reliability at every step. I think we
Every
can
step,
put it that way,
absolutely.
right?
I
Yeah.
think the entire
And
chain of systems, it should be there. Yeah.
correct, correct. And another most important, probably another most important differentiating point compared to maybe last decade, right, is that now this whole ordering, payment, and whatever telecom, whatever you can think of, all this experience is like, you can't imagine the number of transactions that are going in, first of all, right? And too many transactions at any point in time.
Any point of
So
time. Yeah.
it's not just day, I mean, you can't just say, well, I'm open from 9 a.m. to 5 p.m., right? I mean, those days are gone.
Gone.
12 o'clock in the night also, you could have a lot of orders coming in, right? And we would have many examples of that, but
Absolutely,
that has
absolutely.
become the norm. So
Absolutely, absolutely. So, and then it can go up and down also in an unpredictable manner. Maybe some days it may be a predictable, like if there is an IPL match, then it may go up and come down. But yeah, you never know.
correct.
Suddenly
Exactly.
the orders may go
Which
up or
event
go
will
down.
trigger, what events will trigger what, you really don't know. So
Absolutely,
exactly,
absolutely,
yeah.
absolutely. Yeah, yeah.
So
So I think that's
these are the changed expectation, I would say, that which are very different than how you would have built an application or a system
absolutely.
maybe 10 years back. Yeah.
Absolutely, absolutely. So all these expectation, they must have come up with lots of challenges, isn't it? Like to fulfill those expectations, the systems will have a number of complex challenges.
Absolutely. So if
So,
you're a startup or you're a technical person designing an application, right? You have a lot of challenges because of these expectations. Right? So number one, obviously, the volume of data. I mean, it has unimaginable volumes of data today, hitting us, right?
hitting us.
I think there are some numbers of Zomato which I had read, right? I think they used to process few years back, maybe
Yeah,
400 million orders
million.
or
In
something like that.
2020, from 400 million orders they
2020,
processed, and I
two
think
years back.
2 years back. In 2026, it is some 1.6 billion orders, and I'm sure it will
Massive.
be done much before that. Actually, so it's a
Exactly,
huge
exactly.
number. In
Correct,
fact,
correct.
these
And
UPI numbers, the UPI transaction numbers are also huge. Actually, I think it's some
exactly,
5,800 million transactions
correct.
in a month.
I think
So
mobile plus 4G plus UPI, all that combination is a lethal combination, right? I mean,
absolutely,
it
and
will
now
lead
with
to
5G, it's
massive
just
growth
around
in
the corner.
5G around the corner.
Around the
Exactly.
corner.
So
Yeah, yeah,
that's the
absolutely.
first challenge, scales of volume, right? I mean, in unimaginable scale, let's
Yeah,
just say, right? Yeah.
absolutely,
So
absolutely.
that's what it is, and that's first part we'll
First
see.
part.
Yeah.
So huge volume of data, so which was not there maybe 5 years, 10 years back. So now that has
Correct.
become almost like a common norm, actually.
Yeah, exactly. Then second part would be probably around this. Now this data is flowing in, right? But every data is sacrosanct, right? So ensuring that even though the data flows from one point to another, let's say my Zomato app to the server, over the internet, to maybe another banking system, to maybe UPI, NPCL and whatnot, right? It flows through many systems. So consistency of that data throughout the supply chain, and
Yeah,
then
absolutely.
ensuring the durability of the same data, so that if
Durability.
something fails, I should be able to replay that. That's the second
Replay
point I
that.
feel, right?
Absolutely, absolutely. That is very well. And with a high volume, it has become further challenging.
Further challenging, yeah,
Further
exactly.
challenging.
Because how many copies can you keep, and how do you,
Yeah,
at what all places you have to recover, right? So
yes,
that one has to,
absolutely.
keep in mind. Yeah.
And then maybe buffering is required at different levels. Like if a certain system is not
Exactly.
ready to receive, then the sending system may have to buffer the data and then again start
Buffer.
sending it whenever it is available. All those kind of things.
Exactly, exactly.
Yeah.
Right. And like we described, now it is all distributed, right? Because this data is not at just one place. You just don't have one central database and one massive server to look after. You have hundreds of them, and like you said, planet scale. So spread across the planet. You don't even know when
Planet.
you're making a payment. Where is your server? Is it in
Yeah,
India?
yeah,
Is it in UK? Is it in San Francisco? You don't know that, right? So data is
absolutely,
just moving across. It's all distributed data now. So that's the third
absolutely.
challenge. That how do you handle distributed data in
And
this
distributed
fashion?
data.
So
Yeah, yeah. So typically, I'm just trying to summarize. So, by very high level, if we see, like there are multiple systems, but at the end of the day, they are sending data. So one system is maybe getting a data, or maybe from the user, or maybe from another system, and then they are sending data to other systems. So there is a sender, and
correct.
then there is a receiver. And
Correct.
typically, we used to solve these kind of problems using different message queue kind of a products. So I think
Yeah.
something similar we had done in the past, but I think this is a little
Yeah.
bit different. So what do you feel? What difference is there? Because 20-25 years
Yeah.
back also we were having various message oriented middlewares or message bus kind of
Yeah.
products to address this challenge.
Correct, correct. I think we started with EAI, then
Yeah, yeah,
message
absolutely,
bus,
yeah,
then
yeah,
ESB, enterprise service bus, and whatnot, right? Names changed
absolutely,
and
absolutely.
design patterns changed, but problem was the same, right?
Problem was the same.
Senders and receivers, or producers and consumer trying to communicate. Now with this massive scale of data and these
Yeah,
kind of
yeah,
expectation which we talked about, right? Yeah, exactly.
yeah.
So that is where I think the traditional message buses, and I think we have few names right here on the screen. All these are good product, but typically they used to always solve the problem within an enterprise, right? Trying to connect internal application very predictable traffics essentially, right? Even banking, if you think about it, right? Banking has huge volumes, but banking always process the volumes in batches, mini batches, right? NEFT payments. So it was all batch oriented. Now this real time thing is a very disturbing thing for these message buses. So they were not truly architected at that point in time.
Architecture.
So definitely they are useful, but the scale that we are talking about and the kind of evolution that we are talking about, well, you need something different, right? And
Different. Yeah, yeah, yeah.
to handle it. Yeah.
Yeah. So quickly summarize. So because of the huge volume of data and the different expectations and challenges which are there because of those expectations. So what we need is something more than a traditional message bus or the products which are there within the enterprise. So friends,
Yeah.
I think that's where our friend Apache Kafka comes into picture. So Samir, what exactly an Apache Kafka at a high level is?
Correct, correct. I think like we used to always describe, right? Apache Kafka itself describe itself as like a open source distributed event streaming platform. That is like a formal definition, right?
Formal
Yeah,
definition.
but if you yeah, I mean, but if you look at it, I think yeah, and it's good that we have some picture around to look at as a reference. So uh, again, we very well understand the producer and consumers, right? Senders and receivers, and those are the application apps or systems or applications and all that, right? They want to communicate and they want to send this huge volume of data traffic. That is understandable.
Traffic.
Yeah, but how to handle them, and that's where Apache Kafka did few things differently. It introduced a concept of a cluster, which is like a logical cluster you can think of. What you can think of a cluster as a bunch of machines and bunch of processes put together, right? And trying to address the same volume of data by managing that the huge volume and the traffic. So that's your logical cluster.
Cluster.
And
Okay.
yeah, how you form cluster is by putting together a bunch of Kafka brokers or Kafka broker nodes as they are called, right? So you put the brokers, think of brokers as processes or processing units, put on a VM, put in the cloud, doesn't matter, right? And they are the one to which you are actually communicating. So that is where
Communicating.
you establish your communication channel.
Communication
Now your
channel.
communication channel is then called as a topic. So that this is
Topic.
like a basic theme around how Kafka
Theme
designed it.
around.
Yeah,
So basically, there is a producer and then there is a consumer. So and then
correct.
they communicate with each other using brokers. So broker is like a broker between producer and consumer. And then
Exactly.
within the broker there are topics, and the communication
Yeah.
happens by those topics actually by putting message on the topics.
Correct.
So producer produces
The
message on that
topics.
topic, and then consumer consumes it. Okay,
Correct. Exactly. That's the thing. Yeah.
that's the thing.
Um,
So like typically what
and
our pub sub was there, but at a very different
exactly.
scale. Yeah.
Different scale. Yeah. Essentially,
Okay.
you are absolutely right. Apache Kafka ground up is built on the concept of PubSub itself. So they started with the PubSub kind of scenarios, publish subscribe scenarios, and then it evolved basically to handle many more use cases. So that way.
This space. Okay.
So one interesting thing you would have noticed is in our reference diagram is the topics, right? They are kind of spread across the brokers, right? And so that's a good thing that topics are spread across brokers. And at the same time, you will find same topic appearing on other brokers also. So that's also interesting thing because there is always a copy of the broker, a copy of the topic kept across the broker, and we'll talk more about it. And that gives the Kafka real power. We'll talk about that also.
Interesting. So topic is sort of distributed across brokers, something like that. Or?
Distributed across broker, exactly. Yeah, that is where the
Okay.
distribution
Okay.
comes in. Yeah, right. Yeah.
Cool. Cool.
And
Cool.
yeah. And you will
So,
also notice another mention of a partition, and that's also interesting because topic is still logical in a sense.
yeah.
And a topic you can think of, if that is a communication channel, it is divided into partition. That's how we can think about it. And that allows you to, if I have a million records, right, I can just spread them across the partition so that the processing can happen faster, right? So it is distributed and you get a parallel processing through
Parallel
partition.
processing.
So that's the basic,
Basic.
offering from Kafka.
Offering fine. Cool. So I think with this basic introduction to Kafka, so let us, friends, let's understand what is the real power of Kafka. Like where exactly it differentiates as compared to our traditional products which we may have used. So I think the first one, Samir, has our slide is saying like distributed. So I think you have touched it in the previous slide, like the brokers and the partitions and all that. So can you just elaborate a little bit? So with an example,
Yeah. So the good thing about this whole concept of cluster is you can span them across the planet, as you're calling it, right? Which means you can have brokers anywhere. So a VM in your organization, AWS, Mumbai region instance, or AWS, whatever, AWS instance in San Francisco, that way. So they are called stretch clusters. So you can stretch your cluster across the globe, and your broker nodes could be sitting anywhere. So that way you get a lot of distributed power. You can utilize the distributed power of computing over there. So that's one point around the distribution. And that way you can divide the messages and probably use the shortest path and process local data locally and things like that essentially. So that is what it allows you to do. Right. So now there is also a second part of distribution or parallelism and distribution. They go hand in hand, which is we spoke about partitions, right? So again, within a topic you have partitions, right? And that way even partition gets spread over. So even though you are getting million records, you don't necessarily have one server trying to address that, frantic effort to address that, because otherwise you have to put a very huge machine, right? So by having partitions divided across these distributed nodes, now you can leverage the power of distributed computing, right? And so if I'm getting a million orders a day or whatever it is, right, then I can just divide them and have my have them processed through my distributed computing.
Distributed computing.
That's how it tries to address that. Yeah.
Cool. Then the next thing is about fault tolerance. So I think probably that's where also the distributed nature will help.
Exactly. Yeah, because assume one of the node goes down, right? So there's a Pune node broker and there's a broker situated in Mumbai, right? So one of them goes down, the other one can pick things up and start processing from there on. So that is a basic objective behind fault tolerance. And if you go into a little bit more details, how do you achieve that? So to achieve that, right, because it just can't work like that. So for that, what Kafka has done is, so there is a concept of replication, which means the Mumbai node, you can tell the Mumbai node that, hey, please replicate all the data that you are getting behind the scene at a lazy speed to a Pune node and vice versa, or in cyclic fashion to a Chennai node or then Delhi node and all that way. And that way you actually have a copy of your messages. So even if Mumbai node goes down, the data and message and everything is not lost, because even if the broker node takes an hour to come up, the other node can pick up and start working. So replication and concept of leaders and followers. So one of the broker acts as a leader, other one acts as a follower, and that's how the replication happens. And if broker dies, which means there is no heartbeat, and it's actually called a heartbeat, right? So there is no heartbeat. The other one wakes up and says, "Hey, let me play that role and start processing." So that's how that overall fault tolerance is achieved.
Fault tolerance, and this whole thing happens in a sort of transparent manner as far as the external applications are concerned.
Manner.
So producer and consumers doesn't have to worry about it. That's amazing. Right. I think that's the real power.
Absolute power, exactly. They made it very easy for the application developers, to just not to worry about any of this. So you don't have to figure out which is the next one I should go after and all that.
So, that's interesting. But then because of this distributed nature and huge number of data, so probably there will be some challenges like where lots of messages may come, and then for some reason, if it goes down, then as you said, then it will be processed by somebody else. But then what will happen with the, what will happen with the sequence of message, and whether it will be guaranteedly delivered to the end consumer, or how it take care of that?
Correct. Yeah, so there are interesting questions. So there are two aspects to it. One is because to replay a message, right? If something goes down, you got to have a storage. You just can't rely on the memory. So obviously,
Yeah.
the strong point of Kafka is that it stores everything in the physical files, Kafka logs, as they're
Oh,
called
okay,
essentially,
okay.
right? And that it has optimized very well. There are technical details around it, but it uses the OS cache and all that operating system mechanisms to cache and store in a very fantastic fashion. And it uses sequential files. So it's very fast. So even though you think it's a file, oh, it would be slow. No, it's just write once kind of file, right? I mean, in a sense, it never goes and modifies anything. So it's pretty optimized and pretty fast. So that's number
Fast.
one. So that gives you a kind of a durability that you need, so that after that you can replay. And
Okay.
this architecture is replicated across the brokers essentially. So every broker has access to its own files and all that. And then the next question you came to was, this is all fine. So my data in my topics are getting stored, but how do I ensure the ordering? Because otherwise you could have funny situations, right? Like
Yeah.
typically like two transactions are coming in, and one of them tries to add something to your wallet, and then followed by another transaction which tries to deduct, and you are making a payment, right? If that
Yeah,
doesn't
yeah.
happen, the credit transaction doesn't reach, the debit is going to fail. So there will be failure of transaction, and
Absolutely,
you will
absolutely.
think, hey, application is unreliable. So a very very valid question, very very tricky problem always. How Kafka solves it is, even though it parallelizes processing of the data or messages on the topic, it does a sequential processing within a partition. So
Within,
partition is the
okay.
key, or partition is the magic. Anything that is on the same partition, it processes in that exact order. That way it does a guaranteed sequential processing essentially
Okay,
of that data.
okay, okay.
Right,
Okay,
yeah.
cool, cool. Fine. But then
And
all
finally,
those, yeah.
you also spoke about guaranteed delivery. So guaranteed delivery is actually, the interesting thing is, Kafka doesn't try to find out if a particular consumer is awake or dead or whatever, right? It's up to the consumers, and all consumer has to know is which is the last message I process. So I need a number or a handle, right? It's called offset in Kafka terminology. So suppose I start processing as a consumer, right, and I get a bunch of messages. I somehow can't process them. I can reprocess them. I can just say, hey, Kafka, give me a message, give me my orders starting from this offset, or maybe this point in a day of a time or
Point of the
whatever,
time, yeah.
time of a day or whatever, right? Yeah. So that's how it ensures overall guaranteed end-to-end
Yeah, yeah.
processing.
Yeah. So almost like a persistent data store of message. You can read it from any timestamp and
Exactly. Exactly.
yeah.
Yeah.
And then every consumer can read from a different timestamp. So it's not like once a
Exactly.
consumer consumes that. So
Yeah,
that's
we
really
used to
really
have,
powerful. Yeah.
that's interesting. We used to have that problem in the older message buses and all that, right? Because it was
Absolutely. Yeah.
message buses responsibility to deliver, and then it was like
Deliver.
pretty, crazy situation you will land into. So you will need
Absolutely.
huge
Absolutely.
alternate database storage and whatnot. I think all that gets eliminated here. So,
Eliminated. Okay. Amazing. I think with all these things, security also must be a key integral part of Kafka power because it needs security at all these different
all
partitions and
levels,
channels
absolutely,
and everything.
absolutely. If somebody like a bank or a financial institute has to adopt something like Kafka, I think security has to be top notch, right? It has to,
Yeah, yeah, yeah.
satisfy all kind of certification. And it does.
Certificate.
So
That's it.
your basic authorization, authentication, all that is there. Access control is there. The messages which are going on, on the wire, they are encrypted. It supports all standard encryption techniques, data
Encryption. Yeah.
certificate based and whatnot. At rest also, whenever it stores something, you can encrypt and all that. So it's all, everything is in place.
Everything is in place. Cool.
Yeah.
So, so friends, we understood what Kafka is, what kind of problems it can solve, and the real power of Kafka. But before moving ahead, like I will also like to share some interesting thing about a little bit history about Kafka. So, Samir,
Yeah.
there is some relation between LinkedIn and Kafka. So, would you like to share this with our viewers?
Yeah. So LinkedIn is like a father of father of Kafka, you can say, father or mother of Kafka, basically. So yeah, LinkedIn for their own purposes created this beautiful thing, Kafka solution, maybe 12 years back, 2010, right? And we'll talk about those, what was their need, but they created that around that time, and then they realized this is really going to be useful. This will become like benchmark, and they open sourced it. So they released it to Apache Foundation. and it got open source around 2011 and all that. So since then it's all maintained. Since then till now, it's 12 years of hectic development. And what it started with as a small, a small thing, and now a lot of other APIs, open source APIs, have come around Kafka essentially, and a lot of other vendors also have come around it, like Cloudera and Confluent and other things. So, yeah.
Yeah,
that's
so
the interesting history of
interesting thing. Yeah, so this is one of the I think most prominent use case also of Kafka, like how a product or an application like LinkedIn has effectively used it. So there are some numbers in front of us. I'm sure these may not be the latest number. The latest number could be even more than that. So maybe 7 trillion messages per day are processed by Kafka, and maybe thousands of terabytes, and then I think some 1400 brokers and so on and so forth. So I think huge numbers. So basically, what it really tells us is the kind of volumes of data which Kafka can manage in a very, very effective manner. So typically, one can say that web app or web application activity management is the classic use case which LinkedIn has really demonstrated here. Yeah, but it's amazing, isn't it? Like it started with something of their internal project and now given to the entire enterprises, and people are developing amazing applications. Absolutely. It's a great thing. Yeah. Cool. Fine. So let's now quickly move ahead. So we have already seen one of the applications of Kafka, like where the LinkedIn, like basically the second point which you can see on the screen is website activity tracking. So we'll quickly visit that. And I think messaging and website activity tracking, probably we are already a little bit familiar.
Well aware of it, yeah.
Well aware of it.
Traditional messaging and PubSub messaging you can always do, but website activity tracking is the interesting use case. LinkedIn is a classic example of that.
Classic example.
Because you press like or you post a comment and then somebody likes and things like that, right? Or somebody views your profile and is he a HR person?
Which company has viewed my profile and
exactly. Right. So all these kind of website activity tracking, is where Kafka is being used by LinkedIn, and it's the classic example of that. Yeah.
And it is because of the huge volume. I think it is really adding a value because that so many activities are happening on a website. So tracking and then
massive value because one message and many people are interested in that message, right? Because 1,000 of your network, you and I must be having 1,000 people on our LinkedIn network, right? So you put a post, I think it's 1,000 people need to see it, or 1,000 people may click it. So that PubSub is massive, like every click is a message. If you think about it, it's a massive data.
Massive data, amazing, absolutely. Next use case for Kafka adoption is stream processing. So what kind of this stream processing is like? So what are the practical uses of stream processing?
Yeah, I think a couple of things come to my mind. Of course, website information, activity information is one example.
Also like a stream,
that is also is like a stream. But second, if you think about, always comes to my mind, usual example is stocks, right? Stock trading. So a lot of us must be doing stock trading, right? So many stocks, and every millisecond, you are getting a tick. Price goes up, price goes down, right? So stocks, futures, options, all this, right? So if you put that together, it's like a huge data, massive data. It's a continuous stream of data which is coming in, and everybody has different interests. Stocks of your interests are different than mine, right? So we subscribe to their ticks, ups and highs, downs and highs and lows and whatnot, right? So that's a classic example. That stream is going on now. Traditionally, if you want to process, you will take the data, you will try to put it in some massive database, then you will run queries around it, and then you will figure out, is this high, is this low, right? But you can eliminate all of that, right? Kafka has durability. We saw that, right? So Kafka has given nice APIs, streams APIs, and ability to query these streams, which means you don't actually have to store it anywhere, right? Data is just flowing through, right? Your system. And each system which is connecting can make queries on the fly and process the stream on the fly, take some actions, and data moves ahead, right? That kind of thing. One classic example. I can give you another quick one where one of my past companies, essentially we used to monitor network and applications and all that. So what you monitor is like, is the server okay? Which means, is the CPU okay, or is CPU 100% busy, or what about memory? Is it like 32 GB all consumed, and so utilization, all that. That's a massive data because every second
Yeah,
for every
absolutely.
machine, every server, and you could have thousands of servers in an organization. You're trying to get this text, so that's
Get
another
this.
stream of data.
That's
And you want
a
to look at the stream and raise an alert, right? You have no time to
Mhm.
store and think and process and do batch processing. There's no time, right? You have to act fast.
Time
So
for
that's
that.
another example.
That's
Yeah.
amazing, amazing. Next one is, I think, data pipeline. So I think maybe very similar to that, but again, it's like a flow of data across different systems, and then maybe putting into data lakes and so on and so forth.
Yeah.
So yeah, so I think one interesting thing which is coming in my mind is, let's say when you have a complex application where it is already distributed across different businesses and different systems are taking part of it. So I
Yeah.
think analyzing the logs which are getting generated also must be a very big challenge, isn't it? If
It's a
something
big
goes wrong,
challenge. Exactly,
so
exactly, right.
typically, can we use this data pipelines and Kafka to address that
Absolutely,
in a way?
surely. Like I think, yeah, I mean, I spoke about this CPU monitoring data. Similarly, logs is
Mm-hmm.
also equally important because we as developer, as a developer community, right,
Mm-hmm.
we definitely need logs. So gathering the logs from hundreds of, Kubernetes pods and whatnot, right, and virtual machines and cloud and all that, and streamlining them, streaming them, doing quick analysis and raising alerts, or no, even like in a data pipeline, maybe like you said rightly, storing them in data warehouse, running data mining and other kind of analytics, and raising alerts and
Raising
raising
alerts.
alarms. Definitely, it's a perfect
It's a
example of that, and
perfect
it's actually used like that by many of these vendors, log analytics
vendors.
vendors.
Yes.
Yeah.
And then once you have this massive data, then you can run various machine learning algorithms and various AI algorithms to do
Exactly,
some
exactly.
predictive analysis and so on and so forth.
Exactly,
Yeah,
and
very
generate some actionable, information where you can go and take some
information.
actions also, right? Yeah.
Absolutely, absolutely. Amazing, amazing. Fine, cool. So, friends, we have now understood where Kafka can be very effectively used. But then there are certain things which we have to keep in mind before taking a decision of adopting Kafka in your organization. So, Samir would like to highlight. So, what are the key points which a decision maker or maybe even an architect or a developer has to keep in mind before selecting
Yeah.
Kafka in their solution?
Correct, yeah. No, exactly right. Because Kafka is fantastic, we know that, but we also saw when the expectations of an applications are of that nature, huge volumes and all that, right? That's where it really suits you. It doesn't
Hmm.
mean that the other message broker that we looked at, right, Sonic MQs and others, Rabbit MQs and etc., they're not suitable. They could be suitable to you, right? Because you may not have such a huge requirement, etc. And remember, Kafka comes with its own cost. And I don't mean
Yeah,
cost as in dollars, but it's a cost of ownership, right?
ownership.
It's not easy to manage. I mean, I've seen in my organization, other organization, you would have probably only a handful of people who can do that, and they themselves
Hmm.
come at a cost, right? They come at a premium, essentially. So it's
Absolutely,
not easy to
absolutely.
manage either the infrastructure and it requires higher level of
Hmm.
skills, certainly to run it in production at that level, right? So that's, I think, the point to
Yeah,
remember.
yeah. Remember. So I think also the kind of infrastructure which may be required to implement Kafka. So I think it will need significant investment in that infrastructure. So whether it is on premise
Absolutely.
or whether it's on cloud or whatever, but still I think
Right.
huge investment will be required in infrastructure. So that's, I think,
Surely.
one thing one has to keep in mind. So before selecting
Yeah.
Kafka, I think maybe if any other message broker is, if the probably I think if you don't have very vast quantity of data, then maybe some other message broker may also work actually.
Right, exactly.
Yeah, that's interesting. But for this infrastructure, I think there is also some offering from various cloud providers. This managed Kafka
Yes.
actually. So what exactly is that?
Correct, correct.
Yeah.
Yeah. Because see, imagine you putting, let's say you need 100 nodes, right? Which means you have to provision, even if you're using
Hmm.
cloud, 100 EC2s, right, across the globe, and you have to manage them yourself and put them in a VPN and all that, right? I think it's complicated, right? And you will need a team
Complicated.
and a much larger team. This is what is
Hmm.
made easier by cloud providers like AWS, and I'm assuming Prasad, even Azure should be having something similar,
Azure also has. Yeah, I think
where
most
they
of the cloud
themselves
providers are providing. Yeah.
they're providing that. They themselves manage this whole service for you, right?
Hmm.
MSK as AWS calls it, right? It's a managed
Cost
service Kafka essentially. So yeah.
Kafka.
So you just pay for the usage, right? And the infrastructure and making sure the broker is running or not running or scaling the brokers and things like
Scaling the
that is all
brokers.
taken care of by them essentially, right?
Fine.
So
So
yeah.
maybe as a if an organization decides to use Kafka or adopt Kafka, maybe this could be a good starting point. Like do it on a
This is a good
cloud,
starting point. It's a
and
good
then
starting point, but you have to watch your the daily usage and budget very very
yeah,
closely. You wouldn't
that's
you would never know what happens to your credit card
what
after some
happens.
time.
Yeah,
So
because
yeah,
of the elasticity, it can go up very
exactly. Right.
fast.
Yeah.
Amazing.
Yeah.
So that's so really. So just to quickly summarize, so this is really
Yeah.
amazing technology, but I think mainly useful only if you have a very large, vast quantity of data, and that also
Yeah.
a distributed kind of data. Then definitely
Yeah.
this is going to address lots of our challenges which are there.
Right. Correct.
So, perfect. I think that was a wonderful introduction to Kafka. So, friends, we
Yeah.
have reached end of our session. Thank you very much for watching this session. If you like this session, please forward this to your friends, colleagues, and please subscribe to our YouTube channel. Soon we will be coming up with more and more exciting sessions or videos which could be about technology and also various startups which are adopting these technologies in a very creative and interesting manner. So thank
Correct.
you very
Correct.
much for watching this.
Yeah. Thank you. Yeah.
Thank you, bye.